let's continue our discussion. So we are dealing with the income expenditure model when government is incorporated into the discussion. Okay. So again, the question here has to do with first, the determination of the equilibrium output under the assumption that prices are fixed. Prices are fixed. All right. So before we continue, let's make sure one more time everybody here is on board about the impact. Okay, the impact of introducing government into the macroeconomy on the way we write down, particularly the consumption function. All right. So this is the consumption function we have been using when there is no government. It says consumption is equal to C bar, which is autonomous or survival level consumption, and then which is a function of consumption expenditure is a function of households' disposable income. Disposable income. So here, little c is what? Change in consumption divided by change in what? Disposable income. So therefore, little c is the marginal propensity to consume out of somebody. This is the marginal propensity to consume out of which income?
Income. Disposable.
Thank you. Disposable. All right. So this is the original equation. This is the original equation. This is the original equation. As a result, if I want to plot this original equation with consumption on the vertical axis, disposable income on the horizontal axis. So this is going to be a simple diagram with the positive intersect denoted by C bar. Positive intersect denoted by C bar. And then this is going to be a straight line, which is with a slope, which is equal to what? Little c, little c, little c. So this is the changes in consumption divided by changes in disposable income. Everybody? Okay? This is the equation. A straight line, vertical variable, horizontal variable, intersect C bar, slope, little c. And then, once we introduce government, then we know the disposable income is going to be equal to the total income minus households' tax expenditures, denoted by TA, plus the transfer payments that a household can receive from the government. So in our discussion, we're going to assume that the TA is equal to little t times y. Little t stands for the tax rate, which is between 0 and 1. Transfer payment by assumption all are autonomous. So it's going to be a positive constant TR bar. Next, we can combine these two terms, y minus ty equal to what? 1 minus ty. Okay? 1 minus t. So now we have the expression of disposable income, which is different from the total income now because the introduction of government. You have a TA as well as a TR. So what do we do next? We substitute this expression to the right-hand side of the first equation. Substitute the disposable income to the right-hand side of the first equation. We end up with the second way to represent the consumption function. But now, be very alert. The right-hand side variable, the horizontal variable is the total income. All right? So for this equation, which is also a straight line, you have the intercept, which is a C bar plus CTR bar. C bar plus CTR bar. And then the slope here, which is a C times 1 minus T. C times 1 minus T. So by definition, the slope is change in consumption divided by changes in what? Total income. The slope is change in consumption divided by change in total income. terminology. Therefore, this is MPC out of which income?
Total income.
Total income. Thank you. So once again, this is the second time I do this. And as I told you, you're going to see this equations, diagrams, every single time from now on in the 2 midterms as well as in your final. Okay? I'm going to ask you, what is the MPC out of disposable income? What is the MPC out of the total income? Any question about this before we continue? Anybody?
The answer to that question will be changes in consumption over changes in total income. If you ask what is the MPC out of total income, or should we write the entire equation?
Depending on the question. If I ask you what is the MPC out of total income, that's the answer. Right?
Okay, gotcha.
MPC out of total income only refers to the slope. If I ask you to write down the consumption function, obviously it's the entire equation. Yeah?
Okay, thank you.
Of course. All right. So now with this in mind, we are ready to answer the question once again. What is the determination of the equivalent output equal to in the context of the income expenditure model with government? Okay, with government. So here we go again. We're going to start with aggregate demand. In the past, we only have C plus I. Yeah, no government. The aggregate demand only consists of households' consumption plus firms' investment. But now with government, what happened? You have the third term, which is what? G. So what does G stand for? Government purchases of goods and services produced by the firm. Or government spending, in short. Yeah? Everybody? Say yes, please.
Yes.
Okay. So this is the additional term because of the introduction of government. All right. All right. So now, tell me, hey, what is consumption equal to? You say, oh, political, you just told us consumption is equal to this. Agree? Say yes.
Yeah.
This is my consumption function now. This is my consumption function now. This is my consumption function. So I just write out consumption equal to C bar plus C TR bar plus C times 1 minus D times Y. Agree? Can I do that? Say yes, please.
Yes.
Good. Next, what's the assumption we made on investment? We still maintain the assumption that all the firm's investment spendings are autonomous, a positive constant, denoted by what? I bar. Agree? Yeah? Say yes.
Yes.
And then what's the assumption we made on government spending? Same thing, like an investment, all the government spending by assumption is autonomous, a fixed constant, denoted by G bar. Yeah? Agree? So therefore, now I can collect terms. Okay, I can collect terms. I notice that, on the right-hand side of my aggregate demand, I have what? 4 constant terms. What are those? Number 1, C bar. Number 2, I bar. Number 3, G bar. Number 4, C times what? TR bar. Say yes, please.
Yes.
Hello? Okay. So I'm going to collect all those 4 terms together. C bar, I bar, G bar, plus C TR bar. Can I do that?
Yes.
So be very alert. some of you, if not many of you, will miss this term in your exam. You miss one term, your entire question will be messed up. So be alert. There are 4 terms here. Plus C times 1 minus T y. All right. So once again, this is autonomous consumption. This is autonomous investment. This is autonomous government spending. This is MPC out of disposable income times the autonomous transfer payment. So based on the discussion we have so far, what do you think? What I'm going to do next? I'm going to combine these 4 terms all together and then call it a single term. What is it? What do you think? I'm going to call this what?
Autonomous something.
Autonomous something. Thank you. What is autonomous something? I'm going to call that what? A bar, which stands for what? Total autonomous spending. Agree?
Yes.
We used the same notation before, but in the past, A bar is only equal to C bar plus I bar when there is no government. Here we have the presence of government, so we have 2 additional terms. Okay, same notation. Total autonomous spending. Total autonomous spending. So therefore, to answer this question, okay, what is y star equal to? Your first equation is going to be what? Aggregate demand, therefore, is equal to A bar plus C 1 minus T1. Agree? Can I do that?
Yes.
Hey, and then what is my second equation? Very good. Second equation is always the same. What is it? When the economy is in equilibrium, aggregate demand is going to be equal to what? To y. So here we go again. I have two equations with the same left-hand side variable. Are you able to solve, therefore, y star from the intersection of these 2 equations? So yes, please.
Yes.
What do you do? Oh, boy, you have done this. Once again, you put y from the right-hand side of the second equation to the what? Left-hand side of the first equation. So when you do that, what do I get? I get y, therefore, is equal to A bar plus C times 1 minus Ty. Can I do that?
Yeah.
Yeah? Does that make sense?
Yes.
So please tell me, once I reach this point, please tell me you are able to proceed.
Yes.
So what do? You take this term from the right-hand side to the left-hand side. So you get y minus c times 1 minus t y is equal to what? A bar. Agree?
Yes.
And then you put the 1 in front of it. To me, I'm just repeating something I already did. So the 2 terms on the left-hand side can be combined into 1 minus c, 1 minus t, y equal to A bar. Agree?
Yes.
So therefore, what's the final expression for the equivalent output for the income expenditure model with government? You say, oh, A bar 1 minus C times 1 minus T. Yeah?
Yes.
Make sense? Everybody?
Yes.
So this is the entire derivation process for the determination of the equivalent output in the income expenditure model with government. All right. So for those of you who have attended yesterday's TS section, and those of you who are going to attend tomorrow, you will see that in your handout number two, essentially you're going to be asked to solve a numerical example of Y star. After I give you the numerical numbers of a C bar, little c, TR bar, T, I bar, and G bar. Okay? And that question will account for more than half of your first midterm. All right? Here I give you the general derivation. In the exam, you're going to be asked to solve a particular numerical example, just like your handout number 2. All right? Any question about this before we continue? Yeah? All right. Then it shouldn't surprise you to say, oh, Pueblo, I have seen enough econ classes in the past that I know what are you going to do next. What are you going to do next is going to put this onto a diagram. Right? Okay. So as before, we're going to have aggregate demand on the vertical axis. I'm going to have Y on the horizontal axis. Okay. So what I need to do is to plot these two equations. I noticed that first of all, equation number 1 is going to be a straight line with A bar as my intercept, C times 1 minus T as my slope. So therefore, my first equation says aggregate demand is equal to positive constant A bar and a straight line which has the slope which is smaller than 1. So this is the equation number 1, says aggregate demand is equal to A bar plus C times 1 minus T times Y. Okay? So that's my equation number 1 on a diagram. Intercept is A bar. Slope is C times 1 minus T. C times 1 minus T, once again, C times 1 minus T is what we said, the marginal propensity to consume out of which income?
Total income.
Good, thank you. Next, I need to plot equation number 2. This is the equilibrium condition. Aggregate demand equal to equilibrium output, right? So this is the vertical variable, this is the horizontal variable. When the vertical variable equal to the horizontal variable, we know on a diagram, this is nothing but the what? 45-degree line. Agree? Hello? So this is my second equation on a diagram which says AD is equal to 1. So the intersection gives us the equilibrium output of this macroeconomy. Intersection, that is my Y star, which is equal to A bar divided by 1 minus C times 1 minus T. Is that okay? Say yes, please.
Yes.
Okay. So now, let's make sure that you can do this numerically. Suppose I give you A bar equal to 1,000. Okay? Total autonomous spending for the macroeconomy as a whole is equal to 1,000. I have a little c equal to 0.8. This is the marginal propensity to consume out of disposable income. Little t is equal to 25%. Your income tax rate is equal to 25%. Okay? So given these three numerical values, can you tell me what's the resulting equivalent output of the economy? Say yes, please.
Yes.
Yeah. What do? You say, oh, there you go. I just plug in, right? So the new denominator is 1,000. The numerator, the numerator is 1,000. The denominator is 1 minus C, which is 0.8 times 1 minus 0.25. All right. So guys, please tell me you know how to handle the denominator. Say yes, please.
Yes.
So what do you do? What do you do? You say, oh, for example, in this case, what do we need to do is to find out what is this inside the parentheses first, correct?
Yes.
So this is what? This is the high school algebra. All right, minus 0.8. What is 1 minus 0.25 equal to?
175.
Thank you. Okay. Next. 1,000. 1 minus. So you need to do 0.8 times 0.75, right?
That's 0.6.
That's 0.6. $1,000. And then what is 1 minus 0.6 equal to?
0.4.
0.4. Therefore, 1,000 divided by 0.4 give us
2,500.
25. Underline. All right. Okay. So this is the expression, the analytical expression for the equivalent output for the macroeconomy in the context of the income expenditure model with government. And I give you a particular numerical example to illustrate how to obtain a particular economy's equivalent output. When A bar is equal to 1,000, along with little c equal to 0.8 plus little t equal to 0.25. Any question about this? Yeah? Make sense?
Yes.
Say yes, please.
Yes.
Yes.
Yeah? Again, your job here is once you understand how this works, and when you're faced different numbers I gave you in the exam, you should be able to come up with a numerical equivalent output as an integer in your exam. Okay? All right. So now, so this is the determination of equivalent output. Okay? We already answered that in the context of the income expenditure model with government. Now, we want to find out the fluctuations of equivalent output. The fluctuations of equivalent output. So, business cycle fluctuations. Okay? What's the size of business cycle fluctuation? What's the direction? Is the equivalent output going up, or equivalent output going down? If the economy is going, output is going up, then the economy is doing well. The macroeconomy is experiencing an expansion. By contrast, equivalent output going down, then you're dealing with a recession, a contraction of the size of the pie for the macroeconomy. So it turns out that in this case, the fluctuations of equivalent output will be caused by the government's fiscal policy. So fiscal policy has to do with the determination of the government spending and taxes, of a country. In particular, in our context, the fiscal policy refers to changes in government spending. Instrument number one, changes in government spending. Number two, changes in transfer payment. Number three, changes in the income tax rate. Changes in government spending. Change in transfer payment. Change in what? Tax rate. And then it shouldn't surprise you, for each one of them, there are two possibilities. That is, the government spending here can go up. Government spending can or go down. Transfer payment can go up. Transfer payment can go down. Tax rate here can go down. Tax rate here can go up. So in total, you can see that there is a 6 possible cases that you need to learn when you talk about government fiscal policy. Okay? In the classroom discussion, I'm going to discuss increasing government spending, increasing transfer payment, decrease in the tax rate, because all three of them will lead to an increase in equivalent output. And then once you understand how to deal with the first three that causes the equivalent output to go up, you should be able to handle decreasing government spending, decreasing transfer payment, or increase in income tax rate that make the equivalent output to go up, go down by yourself. Say yes, please. Okay? I will do this 3, and it's your responsibility to understand the remaining 3. And it shouldn't surprise you, one of the 3 that you are going to deal with on your own is going to show up in the exam. Okay? All right. Before we continue, let me ask you this. In the United States, what's the process? Who are the key players in determining the government budget? How much to spend, how much transfer payments to give out, and income tax rate? So who decides the U.S. government budget? Huh? How does the U.S. Government budget determine it? It's a negotiation between what and what? Somebody?
The House and the Senate?
House and Senate. And that's one side. What's the other side?
The Fed. The Fed.
No.
The Congress?
The Congress is the House and then Senate. That's one side. Who propose the budget?
Oh, is it the banks?
The what?
The banks?
No. Government budget. Hello. How much government spending? How much transfer payment? How much taxes? Huh?
President?
Is the president, is the White House. So in the U.S., the determination of fiscal policy, particularly the government spending, transfer payment, and the tax rate, are determined by the what? Joint decision between what? The administration, the White House, and the what? The Congress. Yeah? The House and the Senate. Okay. All right. So remember that last month, they just passed this, 1 point something trillion dollars on the infrastructure, correct? Yeah?
Yeah.
That's part of the what? Government spending, correct? Right now, they are in the negotiation of what? Build the what? Better Future, yeah? Act. That's also the entire what? Government budget package. Okay? Okay, everybody?
Yes.
Come on, later on, we're going to talk about, the so-called monetary policy. There, you talk about Fed. Here, everything has to do with physicals. Okay. All right. So here, I'm going to start with the discussion about an increase in government spending. Okay. So I'm going to talk about this one first. So what happened to the economy when there's an increase in government spending? So the initial government spending is denoted by G bar. Now is G bar prime. So therefore, G bar prime is greater than G bar. Okay? So this is the scenario. Okay? The government increases its spending on goods and services. Okay? In 2008, when the US economy was dealing with the Great Recession, January 2008, Obama became the president. One of the first things he did is to increase the government spending, okay? Try to help the US economy out of the so-called Great Recession. So in that context, let's do the following. So we want to analyze what happened to the equivalent output. What happened to the equivalent output? What happened to the equivalent output when there's an increase in government spending? Okay? So the way to do this is you start with A bar is equal to C bar plus I bar plus G bar plus C T R bar. Yeah? So this is what we just did. And then in this case, the resulting equivalent output is going to be A bar divided by 1 minus C, 1 minus T. Agree? Say yes, please. Hello?
Yes.
This is what we just did, right? So now, you say, oh, boy, you're going to have a new level of total autonomous spending. Same level of C bar, same level of I bar, but now you have a higher level of G bar denoted as a G bar prime plus C T R. Agree? Yeah?
Yes.
Good. So without going through the algebra again, please tell me, under the new total autonomous spending, because of higher level of government spending, what is going to be my new equivalent output equal to? What do you think? Using this notation, what do you think? You say, oh, it should be A bar prime, 1 minus C, 1 minus T. Agree? Hello? Say yes, please.
Yes.
Make sense? Again, other things being equal, the only change is that I have a change in government spending. Therefore, I have a change in total autonomous expenditures. And therefore, I have a change in the equivalent output. Agree? Yeah?
Yes.
All right. So now, before I continue, I want to do some house cleaning. Okay. I want to find out, okay, when there's a change in government spending, what happened to my changes in total autonomous spending? Denoted as delta A bar, which by definition is equal to A bar prime minus A bar. So you can see that, please tell me, when I look at the expression of A bar and A bar prime, I notice that these two are the same, right? Say yes. Hello? These two are the same, right?
Yes.
These are the same, right? So the only thing different between A bar prime and A bar is because now you have increase in government spending from G bar to G bar prime. Say yes. Everything else is identical. So when you take the difference between A bar prime and A bar, the only thing left is G bar prime minus G bar. Say yes.
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 And then you say, oh, Professor, this is nothing but changes in G bar, right? Hello?
Yep.
So be very alert, huh? This is going to be a super important property of the changes in government spending. That is, changing A bar is exactly equal to changes in G bar. When you have a change in government spending, you're going to have one-to-one change in the total autonomous spending as well. Government spending goes up by 100. Total autonomous spending will go up by 100. Government spending goes down by 100. Total autonomous spending will go down by 100. It's a one-to-one relationship. One-to-one relationship. One-to-one relationship. On Friday, you're going to see that that's not the case when you change transfer payment. Okay? So be alert about this key property. So now, I want to see when there is a change in government spending, what happened to my equivalent output? So I have the original level equivalent output. I have the new equivalent level output. So what I want to see is what's the amount of my business cycle fluctuation is change in equivalent output, which is equal to y prime minus y star. Y prime minus y star. So question for you. What's the expression of y prime? Oh, here we go. Y prime is my what? New level of equivalent output. Therefore, A bar prime, 1 minus C, 1 minus T. And what's the expression for Y star? I said, oh, here we go. It's A bar, 1 minus C, 1 minus T. Agree? Say yes, please.
Yes.
So you look at these two expressions on the right hand side. Please tell me there's a common term. What is it? You say, oh, the numerators are identical, correct? Yeah?
Yes.
So I can factor out the common term, which is nothing but the numerator is 1 over 1 minus C, 1 minus T. Can I do that? Yeah? Say yes. Times
Yeah.
what? A bar prime minus what? A bar. Yeah?
Yes.
Good. And then please tell me, what is this equal to? Oh, there you go. This is nothing but changes in what? A bar, right? Yeah?
Yes.
But changing A bar is exactly equal to changing what?
Spending.
Hey, G bar. So on the left hand side, you have changes in equivalent output. On the right hand side, you have changes in government spending. Okay? Because at the end of the day, why do we want to increase government spending in the first place? You say, oh, I want to increase government spending because the ultimate objective is to raise the economy's equivalent output. So you want to know what's the impact, okay? What's the size of the impact when you change government spending? Well, the answer is changing Y star divided by changing G bar. Therefore, it's equal to 1 over 1 minus C, 1 minus T. Say yes, please. Hello?
Yes.
So This is what you call the government UVRN, government spending multiplier. MUL multiply MULTIPL. Everybody? Everybody?
Yeah.
Okay. So now let's have a understanding about, what does this mean? Suppose I give you the following number, exactly the same as I gave you earlier. Suppose little c is equal to 0.8. Little t is equal to 0.25. So in this case, what happens? You say, oh, well, then the government spending multiplier in this case is 1 over 1 minus 0.8 times 1 minus 0.25. Yeah? Say yes, please. You plug in little c, 0.8. You plug in tax rate, 0.25 here. This is the resulting expression of the government spending multiplier. Say yes.
Yes.
Good. So what is this equal to? We already did. 2.5. Okay. So the concept, the government spending multiplier amounts to the following. If you increase government spending by $1, then what happened to the equivalent output? The equivalent output will go up by what? $2.5. $1 increase in government spending will result in $2.5 increase in equivalent output. So therefore, if the government spending goes up by 100, what happened to the equivalent output? The equivalent output will go up by hello?
Repeat the question, please.
If this is 100, government spending goes up by 100. What happened to my equivalent output? 100
will go up by
2.5,
250.
250. Agree? Everybody?
Yeah.
So this is how you think about government spending. All right. Next, suppose I give you the other extreme. Suppose C is equal to 0.8. But there's no tax rate. Tax rate is equal to 0. Tax rate is equal to 0. Tax rate is equal to 0. So in this case, what happened? You have change in government spending, change in G-bar. So remember that, this is 250. So suppose the government doesn't tax you at all, okay? There's no income taxation. So in this case, tell me, what happens to my government spending multiplier? 1 minus 0.8, right? Times 1 minus 0. Agree? Say yes?
Yes.
Good. So 1 over 1 minus 0.8. Therefore, 1 over 0.2, which give us, what's the resulting? 5. So suppose I do the same exercise in this case. Okay, I call this economy 1 and I call this economy 2. Economy 1 has 25% tax rate. Economy 2 has 0. Economy 1, the government spending multiplier is equal to 2.5. Economy 2, government spending multiplier is equal to 5. So therefore, in economy 2, suppose you increase government spending by 100. Then tell me what happened to my equivalent output. Equivalent output will go up by
500.
how many? How much?
500.
500. So you can see that in economy 1, output changes by 250. In economy 2, output changes by 500. So therefore, tell me, between economy 1 and economy 2, which economy has a higher magnitude of business cycle fluctuation? Which one? Which one's output will fluctuate more? Economy 2, right? Say yes.
Yes.
Output go up by 500 versus output go up by 250. So this is what? More fluctuations, more volatile compared to economy 1. Say yes. Hello? Hello?
Yes.
So relatively speaking, between economy 1 and economy 2, which economy is more stable? Economy 1 is more stable, correct? Yeah. Okay. So economy 1 has a higher tax rate compared to economy 2. So here comes. In your first midterm, there's going to be an asset question, okay, asking to write down the definition of the so-called automatic stabilizer. Okay. So this is an illustration showing you that proportional income tax rate is an example of automatic stabilizer. So what's the definition of automatic stabilizer? It says any mechanism, okay, any mechanism such as, for example, proportional income tax rate is an example. Any mechanism that is able to reduce, is to decrease, to cut down the magnitude of government spending multiplied. Okay? Any mechanism that is able to reduce the size or the magnitude of government spending multiplied, such that the economy's business cycle volatility is smaller. Okay? Is smaller. Any mechanism that is able to reduce the magnitude of government spending multiplied, such that the economy's business cycle volatility is going to be smaller. Okay. So that's the definition of automatic stabilizer. And I just use this numerical example to show you why and how proportional income tax rate is an example of automatic stabilizer. You have income tax rate of 25% compared to the tax rate equal to 0. The government spending multiplier is going to be lower, smaller than the one when tax rate is equal to 5. All right. Any question about this?
Yes. Could you please explain proportional income tax rate again?
Say that again.
Could you explain the proportional income tax rate again?
Tax rate is equal to 0.25. That means for each dollar of your income, you're going to be taxed at proportional rate of 25%.
Oh, so that refers to T, right?
Yes.
Okay, thank you.
Anything else? All right. If not, this is it. I will see you on Friday.
Thank you.
Thank you.
No problem. Stop recording.